Have you ever wanted to fly? To just spread your wings and take to the air? Seems like it would come in handy. I mean, no more waiting for crosswalks or for an elevator to arrive. Construction would be easier, and tall buildings would be safer if you didn't have to worry about splattering on the sidewalk if you fell out. Guess it's just dumb bad luck that we don't have wings. I mean, evolution is random, right? Wrong. Evolution is a multi-step process, and while the first step of evolution is random, the other steps are not. Evolution begins in the DNA of our cells. Well, in some bacteria it's the RNA, but we'll stick to DNA now for simplicity's sake. In you, me, and that bird over there, DNA acts as an instruction manual. It tells each of our cells where to go, what to do, what shape to take, when to multiply, and so much more. And of course, given that we have a whole lot of cells, this ends up being a ton of information. And when a new cell is formed, it needs to copy all of the information. And the enzymes that do this are very good. They've got an excellent proofreading system. Still, mistakes are occasionally made. Using the instruction manual analogy, letters, words, or even whole sections can be misspelled, deleted, or duplicated. These genetically influenced traits are what natural selection acts on. Natural selection is very much not random. It is quite logical. Let's say that we have a species where there are two versions of a particular gene, version A and version B. Animals with version A produce on average 2 offspring that survive and reproduce on their own, whereas those with version B produce an average of 6 offspring that survive and reproduce. Obviously, with every generation, there will be more and more animals with gene B. It's a simple numbers game. Now keep in mind this only works with the number of offspring that survive and reproduce. You're still a genetic dead end if you produce 10,000 offspring, but none of them live and have kids of their own. Also, let's keep in mind that these mutations work in small steps. A fish is never going to have a mutation and give birth to a salamander. And a fish is never, ever, ever going to have a mutation and turn into a salamander. Let's look at a bird's wing. Now, birds evolved from dinosaurs, specifically a species of small, forest-dwelling dinosaur. This dinosaur didn't have wings, it had arms, but it did have feathers. Feathers are a modified form of scale. They were probably originally an advantage because they're much better for insulation than scales. And so the dinosaur had some feathers for insulation, but probably also some larger feathers, maybe for display to mates. Now this dino could climb into trees and jump between them. Now the slower you fall, the further you can go on a single jump. Thus, it was an advantage for the dinosaurs to have something to help them glide. Longer feathers on their arms served this purpose well. So more mutations built up over time, making the feathers on their arms larger, stiffer, better at catching the air. Eventually, you had a dinosaur that could not only glide between trees, but also raise itself higher into the air by flapping its arms, which by this point we'd probably be better off calling wings. Now, they didn't look like the wings on a modern bird, not yet. Modern bird wings are very specially designed. Their feathers are asymmetrical, with different lengths and different shapes, forming an aerofoil. This shape allows a bird to produce lift simply by moving through the air. Our airplane wings are designed in a similar system. So, why didn't something like that happen with our ancestors? For the sake of this mental exercise, let's not go any further back than our earliest ancestors who were upright primates. After all, what we really want is to be winged humans, not bats or birds. To get bird wings, you obviously have the problem of our ancestors didn't have feathers. And out on the African savanna, is an advantage to have less insulation, not more. We lost our fur. A mutation to turn what little fur we had into poofy feathers wouldn't have been an advantage. So what about bat wings? It'd be relatively easy to get a mutation to put webbing between our fingers. But that's not really going to be enough to keep us in the air. Even when our ancestors were short, they were still too big to glide with that little bit. Even if you managed to get a mutation that would put webbing between your arms and legs, it still wouldn't be enough to serve as much of an advantage. And wings like an angel sprouting out of our back, while that would be cool, would be even more improbable. The muscles and bones of our back already perform important functions, helping us move our arms and torso, and protecting important structures like our spinal cord, our lungs, and our heart. Anything that gets in the way of those structures, like a little lump that could someday grow up to be a big wing, would just be a disadvantage. It'd get in the way. So, short story is, we don't have wings because the steps along the way were never an advantage for our ancestors. They were better off devoting their energy to nimble hands and big brains. And I'd say that worked out well for us.